Good morning, everyone. Mic is on. Okay. Oh. By the way, I found myself in. I found myself at the floor at 3 a.m. in my house. Yeah, I'm tired a little bit, but I'll start my presentation. Today I will touch upon those topics. Since this is the first face-to-face AMM in Japan in a long while, please allow me partially to repeat the presentation contents in that past blank period. So because this is an agile community, I know everybody here already understands the most part of vehicle evolutions or innovations from now on will be realized by software. So it's enough to say in this slide today that SDV is a game changer to the new game where those who can advance their software more rapidly will gain crucial competitive advantage. So therefore, the ultimate essential purpose of EE architecture change is not to reduce the hardware cost. Well, it's true, but not the essential purpose. But to enable to accelerate the software evolution to the highest degree for SDV. Open source software will be heavily utilized and de facto standard will grow to establish strong ecosystem for SDV evolution. Cars are always connected for software update and massive cloud services for rapid SDV innovation, and so on. Those are because they are the most competitive way of evolution and innovation in SDV era. But this game is not as simple as just to maximize line of code per month, nor just to possess even larger software team. There are far more important factors such as sophisticated architecture, which makes the software asset more valuable for longer term, ecosystem of complementary products, which makes value of your product higher, and faster speed of product discovery as well as product development. In such SDV world, we should no longer design vehicle system driven by physical architecture like the left side figure. We should take logical architecture-driven design like the right side one. Physical architecture of vehicle will change drastically every generation, but software should be decoupled from such volatile hardware so that software can evolve continuously beyond such hardware change. So well-designed logical architecture makes it possible. In this context, hardware virtualization has been the key technology. We can learn from the critical importance of virtualization technology in the history of the preceding computer industry. So every generation, the computer architecture has been changing drastically with going back and forth between distributed and centralized, driven by the evolution of semiconductor technology. In such situation around 1970, very old age, IBM introduced a unique strategy in those days. They introduced hardware virtualization technology to make their software work over several generations of hardware because they thought software was most expensive asset like we do today. So it made IBM the exclusive champion for a long time. This shows the critical importance of logical architecture and virtualization technology as well in software-defined products. But these days, we know we need to consider a healthy ecosystem so as not to be locked in carelessly by some evil one. Actually, the situation around virtualization in automotive industry has been very dangerous because of proprietary interface around each specific hypervisor. So Panasonic Automotive has been playing the leading role to solve this issue since 2018 by developing and promoting automotive feature of VirtIO to make it the automotive industry standard. OASIS is the formal standardization body of VirtIO, actually. But AGL and its virtualization expert group has been always our home ground to discuss the design, deploy, verify, and demonstrate the implementation within the full-stack automotive platform called AGL UCB. Thus, AGL has been the incubator of VirtIO, as Dan mentioned. I deeply appreciate the contribution by this great developer community. As the result, AGL, Android are being developed, and the Sophie is going to be developed based on VirtIO. VirtIO has already gained a huge momentum. This is a great success, but still today, the real support level of VirtIO by each existing hypervisor seems considerably different. If you are to choose a hypervisor for your product, I have to say you should be very careful about that. But anyway, we are working on further significant evolution of VirtIO, not only for hypervisor environment like the leftmost one, but also for device virtualization for non-hypervisor environment, which leads the industry to establish the decoupling between software and hardware for both hypervised and non-hypervised system. Location-independent hardware access in the multi-SOC or multi-ECU environment, and also cloud-native environment by realizing the virtual hardware environment in the cloud. So again, hardware will change drastically also from now on. So current central integration of computing trend will not be permanent direction. There's already distributed computing trend emerging with high-performance interconnection technology. Virtualization is always key. Next topic is the display system virtualization. In vehicle cockpit environment, there are a number of heterogeneous displays in various locations, including head-up display, digital mirrors, instrument cluster, and so on. So it should work as an integrated display system to realize such a rich cockpit experience as this slide. While the basic display unit level virtualization is covered by VirtIO, but for the display system level, we need a higher level, we need a higher level of virtualization to realize location transparency. To solve this, we developed display system virtualization technology called Unified HMI, by which any ECU or virtual machine can render its information at any place of any display. This page shows the concept of Unified HMI technology. Unified HMI presents a single unified virtual display to application programs instead of presenting multiple physical displays. By this mechanism, each application program can render its information to anywhere of any physical display technically. Of course, rendering permission of each application is controlled by Unified HMI system according to the system policy. Unified HMI software has been developed by Panasonic and it's already up and running. And for the system interoperability between ECUs or virtual machines developed by various players, Panasonic has made the Unified HMI code open source and it has been already committed to AGL UCB. So please join the Unified HMI session Thursday held by Murakami-san from Panasonic for the technical detail. So next topic, application frameworks are another important pieces as well as virtualization frameworks as the technology enablers for SDV. Recently, AGL has been playing the very important role as the incubator for those key enablers for SDV, as shown in this slide. As similar as for VirtIO, by discussing the design, deploying, verifying, and demonstrating the implementation within the full stack automotive platform called AGL UCB again. I would like to mention one of those key enablers among those here. Container and the Mesh Expert Group has been working on enabling AGL to running on the cloud together with Virtualization Expert Group. They are realizing workload orchestration for AGL across the single or multiple nodes inside and outside vehicle. Very impressive. So those two expert groups, Container and Mesh Expert Groups and the Virtualization Expert Group share synergy in the way that they are trying to achieve the same goal, that is decoupling software from hardware. They have already been working back to back with each other since the previous year to accelerate AGL movement towards cloud native. And now, so as Dan mentioned, I'm very glad to say a new expert group named Software Defined Vehicle Expert Group has been established by combining expertise of two original groups in device virtualization and microservice orchestration. Panasonic is to lead this new expert group. Jerry-san will be the leader, tightly collaborating with various members, including AWS, who had been leading the Continent Mesh Expert Group. Now they are having a series of heated discussions to accelerate SDV further. Please join relevant session held by Jerry-san from Panasonic, the leader of the expert group, slightly after my session. Next to Munakata-san's session. Yeah. So please join. So this is my last slide. These days, a number of various open initiatives around SDV keeps arising in the world. So now is a good timing for AGL to reconsider its role or positioning among them. I enumerated some instances of initiatives in this slide. So when I look, I think AGL has a unique set of features that makes AGL capable to play the role which other ones can't play. AGL integrates full stack of software which includes the codes which has been developed by external project. Of course, it's open, and in addition to that, AGL owns distributable reference hardware to actually run the integrated code on top of it. By this really code-first approach, AGL has been focusing on software and hardware that can actually run. And AGL has been maintaining it continuously as its primary artifact. Furthermore, if we need, new expert group can be created relatively easily, and a relevant member can collaborate openly on new topics. So if you are to develop some new technology, AGL is the ideal reference platform on which you can embed and evaluate, verify, and demonstrate your technology. And while working with such code-first approach, you can openly discuss and collaborate on the technology with members of various backgrounds. That's AGL. Is there any such open place elsewhere? I don't think so. So through our own experience to bring up VirtIO and Unified HMI in such place, I really feel AGL's role as the incubator of technologies is so significant and valuable. We need a lot of various initiatives for SDV except for AGL also. But I am quite confident about the importance of AGL's role. I believe AGL community should work together with even wider open activities in the world with its code-first approach. The wider the collaboration and the incubation is going to be, the higher the value of AGL in SDV will be. That's all of my presentation. Thank you so much for your kind attention. Thank you.
Thank you.